Hi, welcome to lesson 22E, compound events. Compound events are basically when there are two events that are occurring at the same time, and we want to find the probability of some certain outcome. So one of the things that we've looked at in the past, rolling a die and tossing a coin. That could be a compound event. I mean, there's millions and millions of other examples. I just can't think of one at the moment. So we're going to do a little investigation here, and we're going to toss a coin and roll a die at the same time, and the result will be called, the result of the coin toss will be outcome A, and the result of the die roll will be outcome B. Whether that plays a huge role in this or not is yet to be decided. Okay, so we're going to use a two-dimensional grid here, and we want to see the probability that a head will be rolled and a head is tossed and a roll of 4 from the die. So of course, and means both. So we have to be prepared for that. And of course, if it's a head and a 4, then we're looking at this intersection right here. And so of course, there are 6 possibilities for a die, 2 possibilities for a coin. So together, there would be 12. So we've got a 1 out of 2 1 out of 12 probability that what results of the coin toss and the die roll being a head and a 4 is 1 over 12. The next probability that we want to see is what would the probability be if a head it comes up from the coin and an odd number results. So we got a head and an odd number here, head and an odd number, and a head and an odd number here. Okay, so those are only 3 possibilities, or 3 possible outcomes. Of course, that again is both, out of a total of 12. And that can simplify to 1 over 4. We want to see the probability of a tail and a number larger than 1. Okay, so a tail and a number larger than 1. So we've got a tail and a 2, tail and a 3, 4, 5, and 6. So out of all the 12 possible outcomes, there are just 5 that fit this description, a tail and a number larger than 1. Okay, and we can't simplify that, so that just stays as it is. And then we look at a tail and a number less than 3. Well, a number less than 3, and here's a tail, so here's a tail, and a number less than 3 is 1 and 2. Okay, so we just have 2 possible outcomes there. So this is 2 over 12, which simplifies to 1 over 6. Okay, so this is all fine and good using the two-dimensional table here. But maybe there could be an easier way, a more straightforward way of finding these. So if we look at these different outcomes, they both are resulting from a coin and a die roll. So a head, well, for part A here, we have a head. The probability of a head is 1 over 2. Okay, that's the probability of a head. And the probability of the 4 is, of course, 1 over 6. Now, of course, notice also that the flipping of the coin and the rolling of the die don't affect each other whatsoever. Okay, so whether the coin turns up heads won't affect that the die rolls up with a 4 and vice versa. Okay, so now notice if we take a look at this 1/2 and 1/6, well, if we go up to our two-dimensional grid here, and we see the actual result was 1/12. Well, how are we going to get 1/12 when we have a 1/2 and a 1/6 there? Head scratcher. Let's take a look at another example first, and then maybe we can circle back here. A head and an odd number. Well, a head again is going to be 1/2. That's the probability of a head. Whoops. And an odd number, well, we know that there's 1, 3, 5 on a die, so there's 3 out of 6. And that, of course, can be simplified down to 1/2. And what was our result here? And actually, maybe I'll just write this down below here. So this is, we'll just write it down here again. This results in a 1/2 as well. Now, what was our result from above here? A head and an odd number became 1/4, or 3 out of 12 as it started out. Well, how are we going to get 3 out of 12 or 1/4 from these values? And remember, for part A, we had 1/6. Well, we'll come back to that again. And if we look at part C, a tail and a number larger than 1, well, again, the probability of tail is 1/2. And the probability of a number larger than 1, well, there's going to be 5 out of 6 in that regard. And our answer, remember, up here is 5/12. And one last example here for part D, a tail and a number less than 3. Okay, again, the probability of tail is 1/2. And the probability of a number that less than 3, well, it was less than 3, not just less than or equal to, and that's 2 out of 6 because we had a 1 or a 2. And of course, that one can be simplified as well. So we'll leave that 1/2. That can be simplified again to 1/3. And notice that the result here was 1/6. Okay, so all of these, remember that this ended up being 1/12. This started out as 3 out of 12 before simplifying to 1/4. This was 5/12 probability, and this was 2/12 before simplifying down to 1/6. Okay, so I'm sure by now you've seen the pattern to see how all that works. And without further ado, notice that if we multiply fractions, well, of course, as you realize, when you multiply fractions, you just multiply straight across. None of this cross multiplying stuff that people get in their heads when they're looking at fractions. You just multiply straight across, numerator with numerator, denominator with denominator. And so if you were just to multiply those, and we're multiplying straight across, we get the values that we got above. So that then looks like that is the key. If you have the probability of two events that do not affect each other, then you just multiply the probabilities together, and you'll get the resulting probability without the need of drawing a two-dimensional grid. So, silky segue into independent events. So events are independent if the occurrence of either one of them does not affect the probability that the other occurs. It is not going to affect the occurrence of it, but it is not going to affect the probability of the other event occurring. So in the investigation, rolling a die and tossing a coin are independent because they don't influence each other. And so if we're to use this formula, the probability of A and B occurring, here's our events A and event B, probability of A and B occurring is the probability of A multiplied by the probability of B. And so we can even extend this to 3 events or 4 events. It doesn't matter. It all just kind of works out as long as they're all independent events. So if we don't want to use a 2-dimensional grid and we toss a coin and we roll a die and we want to find the probability of getting a head and a 3, well, that's going to be the probability of getting a head multiplied by the probability, the probability of getting a 3. And we know the probability of getting a head is 1/2. The probability of getting a 3 is 1/6. Therefore, the probability of getting a head and a 3 is 1/12. All without using a 2-dimensional grid. Now, that was with independent events. What if the events are dependent? So dependent events basically are subject to each other occurring. So the occurrence of one event will have an impact on or will affect the probability that the other occurs. Okay, so the probability of the second one will be affected by the first one occurring. So if we were to draw a card out of a deck of cards but not return it, instead of there being 52 cards to choose from as there was in the first case, when we first picked a card, now there's only 51 cards remaining. Okay, and we also have to know what that first card was, okay, in order to do that, or to figure out the probability. So the probability of A then B is the probability of A multiplied by the probability of B given that A has already occurred. And I'm just going to stick in the word here, already, because that is kind of important. And here's that given that again, given that. And we write this like this way, the probability of B given A, okay? But given that A has already occurred. So A already occurs. So given that A has occurred, what's the probability that B occurs after that? Okay, so from a box that contains 4 red tickets and 2 yellow tickets, 2 tickets are randomly selected. Again, always randomly selected. From the box, 1 by 1 without replacement. So we're not putting them back in the box. Thus, the total number of tickets when you pull out the second one has changed. Okay, so if both are red, so we're going to say red and red, then when we first pull out a ticket, there are 4 red tickets out of a possible 6. And then if we pull out a second ticket, well, there's only 3 red tickets remaining, and there's only 5 tickets remaining total, because we already took one of the 6 out when we took that first red one. Okay, so then we just multiply straight across, and we get 12/30, which simplifies down to 2/5. If we look at the probability that the first is red and the second is yellow, so we'd say the probability that yellow, given that the red has already been taken, well, the first is red, so we got a probability of 4 out of 6, and then the second one is yellow, so there are 2 tickets, 2 yellow tickets, and so there's still 2 yellow tickets, even though we've already chosen a red one. And there's only 5 remaining, 5 total tickets remaining, because 1 has already been chosen. Okay, so that's why we have 2 over 5 in that case. So then we multiply straight across, and we get 8 out of 30 is the probability that this would occur, and that simplifies down to, what's that, 4 over 15? Okay, so there's a 4 in 15 probability that you select a yellow ticket, given that a red ticket has already been selected. Okay, so this is how we can see how probabilities change as we move through dependent events. Okay, and that is it for this lesson 22E. Thanks for watching, and we'll see you in class.